Thank you. Appreciate it. Thank you, everybody, for joining the call today. This is as they say in Europe, the OCA, as we say here, the OCA, the Open Charge Alliance. First of all, thank you very much for letting us speak, Michael and me, on the future of electric mobility, particularly looking from the lens of what's happening in electric transportation in the United States. But we also kind of look in the perspective of what's happening across the, you know, planet as well, and we do have some suggestions across all the OCA members. I'm Rish Ghatikar. As some of you may know me, I've worked in the electric industry extensively for almost over a decade now. I work primarily in the energy sustainability, grid integration, EV, and distributed energy resource technologies. I'm not a policy guy, I'm a technology guy, and work a lot on the understanding the technology and the role technology can play in addressing some of the sustainability issues that we face. I've worked with General Motors in the past as an energy fellow, Electric Power Research Institute, which is a utility industry based here in the US and working globally. And my work actually, in the whole energy sector started almost like 25 years ago to USDOE's Lawrence Berkeley National Laboratory, which is one of the national labs in the country, where I kind of led a lot of technology development for what we call automated demand response, virtual power plants, energy services. Now, one of the standards that came out of that, OpenADR, was my invention and the work that I did at Berkeley Lab. And then, collaborated with OCA during my Green Lots days, which is a Shell Recharge Solutions company now. That was in 2015, 2014 when OCA was found as one of the founding members. So since then, I've been very engaged, and recently, I've been ambassador to the OCA, and it's a great opportunity to be involved again and discuss some of the key issues that we're facing in electric transportation now, and how we can help the community grow together. I'll let Michael, kind of introduce himself. Over to you, Michael.
Hi all, Mike Barnard. I'm a broad spectrum nerd who looks at all the global issues related to climate change and all the purported solutions, assessing them on the basics of technical viability, economic competitiveness across a broad spectrum of solutions, and whether human beings will accept them. And then I do projections out through 2100 of major areas, including transportation, steel, cement, stuff like that, of scenarios of decarbonization based upon which solutions I think will be economically competitive and hence will win. And obviously that means for transportation, all ground transportation will electrify. And then what do we do with trucks? And trucks will be electric as well. And so that led Rish and I together in some of this stuff to the focus of this webinar. Within that context, though, my day job is advising firms and investors, infrastructure investment funds and venture capitalists about how to spend their money more wisely and more quickly on things that will actually move the needle. Rish, back to you.
All right. Thank you, Michael. Thanks for the introduction. So what do we have on the agenda today? As Hannah mentioned, we do have 1 hour, 15 minutes. We'll try to kind of wrap it up in probably in 50, 55 minutes and give you 15, 20 minutes for Q&A, because I always like presentations that are more interactive, not just one way. In the meantime, if I understand correctly, Hannah, and people are welcome to post questions on the chat that we will continue to look and collate at the same time. So if you do think about any questions on the slides we're presenting, please feel free to type them out on the chat, and we'd love to hear from you. So the agenda that we've carved out is slated in 4 different sections. I'd like to start understanding the fact that the OCA members are all over the world. Although we are focusing on the US perspective in this particular presentation, as I mentioned earlier, we are trying to see how this could be globalized. OCPP is a global standard. Electrification of transportation is a global phenomenon. The carbon and decarbonization issue, electrification is a global phenomenon. So we have tried to really touch upon some global issues wherever is possible, but a majority of the content and the understanding is from the lens of the US perspective. Hopefully, when you think about what's happening in the US, you can relate to what may be happening out there, or how we can take some of the lessons and experiences and apply that to your specific company or your specific country. So from that lens, we'll touch upon the electric landscape. What are some of the trends that are happening in the landscape, particularly with the transportation sector, and how its transportation sector for electrification is kind of inextricably linked with the electric grid, another very important and long-standing industry. And then we will talk about the disruptions that are happening in the United States. And this is based on my personal experience and many studies and data that I have published on what is happening in the EV charging industry, which comes to the, or has direct linkages with what's happening with the OCPP. Particularly, I'm going to talk about the union bi-directional charging, the standards, and the role of OCPP within this context. And then I'll pass it on to Michael, who is going to talk about the electrification strategy for transportation from the trucks, heavy duty and medium duty trucks, and some of the key strategy and case studies out there. In fact, he's going to have a very surprising announcement today as well for the first time at the OCA at this particular webinar, and hopefully Michael will do that honors. And then I will kind of wrap up with the future of open standards. This community, as the term open is kind of prevalent in most of the things we do, OCPP or OCA and other many different standards. What is the evolution of OCPP, in particular looking from interoperability across not just the EV ecosystem, but also across the EV and the grid ecosystems. And we'll talk about a little bit about the industry collaboration and seamless integration that's necessary. And then we'll leave some time for Q&A. With that, what's happening in electric mobility and global trends? I mean, most of you may already know what's happening, but let me touch upon some things that are very important and the questions that are arising as well. Over a decade since I started working on this industry, almost in 2013-2012 period, when we're looking at electric vehicle and its role with the grid integration. In fact, we set up the first microgrid and vehicle-to-grid integration project here at LA Air Force Base in California, a project that started in 2011, 2012. That was part of my work when I was still at Berkeley Lab. We were looking at how the vehicles can integrate with the electricity market along the same lines of what we had automated demand response, or now it's called a virtual power plant, right? So we have seen a significant change and trajectory in the transportation sector and electrification of that transportation. Particularly if you look from the global lens, right, we have seen as of 2024, the electric car sales rose by 25% to 17 million globally. And we do know that majority of those are focused in three primary regions. China is the leader, okay? Almost close to, 3 in 5 vehicles sold are in China. And you look at Europe, where OCA is based, almost 1 in 4 vehicles sold are in Europe. And then when we look at US, which is the least, but in terms of the vehicle adoption, it's pretty immense, right? Almost close to 500, 600 million of vehicles on roads here in the United States. So, 10% of is where we are, 10 to 11% approximately. This is a 2033 figure. To look at 24, maybe 11 or 12% is where we are in the United States. The question really comes is what is driving these, right? So when we think about what's driving this, one question I keep getting asked all the time recently, hey, what's happening in the United States? What are the policies? How are they going to, or the politics, not other policies, but politics are going to change how we're looking at electric vehicle. And I tell people, every technology we need to build, every business we need to build, every disruption we need to build, we need to look at from the policy perspective, technology perspective, not rely on politics, right? So that is the angle I'm going to take a look at from, is how can we influence the policies, how we can develop technology and ecosystem that helps us to transform the industry in a very positive way and not so much be driven by what happens in 1 year, 2 year, 4 year period. So that is driven, if you look at the history of decade, it's the policies that have driven favorable policies, of course, in the initial startup, in the adaptation phase. The technologies have improved immensely. If you look at the vehicle technology, the improvement in the battery, the improvement in the sensing, the improvement in autonomous vehicle operations, and in general improvement how vehicle interacts with humans and how vehicle interacts with an electric grid, that has been transformed immensely. Even I used to think that electric vehicles are pretty advanced 10 years ago, and if you think about what's happening with electric vehicles now, it's just mind-boggling, right? But there is also a very important link of those vehicles with electrification targets, right? And as we know that electrification is a key part, and battery plays a very important role. Of course, we talk about electric vehicles, so we can think about hydrogen as well, but in this case, we're talking purely from the battery vehicles, and I do see that battery vehicles are the future, not so much hydrogen. And Michael is an expert; he can talk in length for next an hour or two on why hydrogen is not a good idea. But in this case, knowing that the battery is approximately 40% of the cost of electric vehicles, and that plays a very important role, we are seeing the economies of scale of batteries are driving the cost of the batteries down as well. Of course, technological improvement. We have seen that battery demand surpassing significantly, driven by both stationary storage batteries as well as the batteries that are required to run on electric cars, and that's probably a good thing. And if we see the trajectory, we do see the trajectory that the battery costs are going to fall even further, and that might help better cost of the electric car. And that's what I meant by the policies and technologies driving the need as opposed to the politics. When we talk about the US, right, what's happening in the US? Of course, in the US, we do have 6 million plug-in electric vehicles. When I talk about PEVs or plug-in electric vehicles, I talk about both the hybrid vehicles as well as the battery electric vehicles as well, plug-in hybrids and the battery vehicles as well. So we had around 6 million PEVs, and I'm talking just from the passenger vehicles, right? Light duty and medium duty vehicles, passenger vehicles, and not so much on the trucks and other kind of transportation. I mean, the forecast and the data kind of shows that sales will continue to grow. Right? It just could be at a slower pace, primarily driven by some of the shocks we are seeing with the administration, the changes that may happen here with respect to the incentives and the EV incentives and the charging infrastructure rollout plans. Although the incentives are still there, at least in the U.S. for now, we'll see what happens. But as long as we can show electric cars are economical and it's good for the country and good for the citizens and good now for environmental reasons as well, that should be a good driver to continue adopting vehicles. Another thing we are seeing big change in the U.S. If I remember correctly, had last year as of now around 78, 80 models of electric cars in the country. And that's quite significant. And 10 years ago, when I could even count, oh, there's an electric car, that person released an electric car. We just lost track of it because there are not a lot of new models are coming. And the falling battery prices and incentives are all kind of driving adoption for the drivers. The next link of the electric car adoption comes to the charging because you need to have adequate charging. So if you look in the regions like California in the US, you look at the Washington or New York, they have the highest, even Florida, for example, they have the highest adoption of the charging infrastructure across the country. And that adoption is also driving people's confidence, the range anxiety and charging anxiety, some of the anxieties that we know about, right? Alleviate some of those concerns and buy an electric car. At the same time, we can't think about charging infrastructure without thinking about the electric grid and the industry of the electric grid industry, where it becomes very important to start looking from that lens. We are seeing in the United States, time taken to deploy chargers are taking much longer, primarily from the interconnection requirements. The interconnection queue is pretty long. It can range anywhere from 6 months to 6 years or 8 years to 10 years, depending on the size of the interconnection that you're asking. So the question really comes is, how do you enable a charging infrastructure work with the electric grid industry in a way that the power is available when we have to charge the car, and so the customers feel comfortable. So at the end of the day, for me, everything, the charging infrastructure, the grid industry, The energy management strategies that are required are all the means, the end, which is how can we sell more electric car and move to the electrified future. When we talk about the electric grid and the link to move into the electric future, we all understand that just the electric transportation industry cannot drive the adoption. You need to have a very close link to the electric grid industries as well. When we look from the transportation side of things, you know, we do see that a lot of electrification growth or demand is coming. A lot of people talk about electric cars, but it is also driven by industrial end users here in California. And now, for those who have kept in touch with the day-to-day changes happening, what we call hyperscalers or these gigawatt scale data centers for artificial intelligence, are all driving a significant forecast and higher demand that we would see. The data that I see is just phenomenal. I used to work on data centers and flexibility. 12 years ago, we published a lot of studies and findings working with NetApp, working with Facebook, working with the supercomputing centers, etc. We were looking at 1 megawatt or 5 megawatt, 10 megawatt as big data centers, and we're talking about gigawatt. The scale is just immense. And how do we balance this across the electrification? So not just thinking from the lens of electric transportation and needs, but also in the needs of the collective, electrification and the needs of those, other end users as well. And when we talk about the charging infrastructure, US had approximately 170,000 public chargers. So there are a lot of forecasts in terms of the growth that one needs to be into, where the electric vehicles need to adopt, 30%, 50%, 100% adoption, and how many chargers we need. We are nowhere close to that, right? We are maybe at 15% of what we need eventually for deployment. This is the Bloomberg data. And the link to this is how do we make these chargers interoperable, right? And make sure that these chargers are available all the time. And OCPP plays a very important role in enabling the charger to be available and be managed by any network and the upward and downstream interoperability. I think that's very important. Downstream, I call primarily with working with the vehicles. Upstream, I call charging operator and electric grid utility markets, etc. So when we talk about the markets and the grid integration, one thing we have seen is the NREL report. This is the work that I do a lot. I work in the buildings, I work with the industrial sectors, and now with electric vehicles and batteries extensively, is the NREL study, National Renewable Energy Lab, another DOE national lab. I said, in case we don't have unmanaged charging, we can increase the peak demand just from electrification of transportation sector by 25% in some states, particularly the states that I mentioned, the regions that I mentioned earlier. And that means that there is a tremendous flexibility we can think of. We talk about public charging. What we don't talk about is the residential charging. 85% of the charging, a lot of Berkeley studies and other studies at JD Power, etc., has shown 85%, 85% of the charging happens at home. And so when you talk about the home charging and the home needs, and a lot of times home charging are in the evening or nighttime charging, how can we shift the charging from a peak time or when the sun is not shining or wind is not blowing into a time when the electricity is abundantly available or low price is a very important question that we need to continue to ask as technology becomes proliferate across every part of our lives. And this is where the vehicle grid integration, or terminology we use, grid integration, we talk about integration of vehicles with electricity markets, etc. But the VGI is a kind of a term that is used by in the US extensively to enable an interactive link between the electric vehicles and the electric grid, and how VGI helps manage the grid demand. There are a lot of transportation programs and utility programs in California, Texas, and New York that allows this to happen. And I'll touch upon that in a little bit more details as we progress. So we talk about the grid integration. This is a framework, and this is a framework that is being extensively, even internationally, and this is something that I worked at Lawrence National Lab with my colleagues and got that published. It's called the Linking Continuous Energy Management, an open automated demand response. We were looking from the building's perspective at that time, whether it's a residential building, commercial building, or industrial facility. As you see on the left side, there are tariffs, utility tariffs that each of the buildings that needs electricity participate with utility. Their time of tariffs primarily driven by the large commercial industrial facility, but now they're applicable in recent last since 5 6 years in state like California, and I expect that trend to continue in other states as well on time of use rates, where the price of electricity is more expensive at certain times of the day and less expensive at certain times of the day. So the question, and then as you start moving towards the right side of those triangle, you're looking at more dynamic rates and ancillary services. Ancillary services are the services that large power bulk generating systems are there just to support electricity use for certain hours in a year where the demand is extensive or are needed on a very short term basis. So when we think about that, we talk not just about enabling a service all the time, but also a service where you can temporarily reduce, but has a tremendous benefit overall society in terms of what the peak year plants or typically the fossil-based generation plants. But now, at time, we did not have an extensive amount of renewables in the grid, and now it becomes even more valuable to address the variability of the renewables. So what happens all of a sudden you have a cloud cover? What happens all of a sudden the wind stops blowing? So there is a tremendous, of course, battery can supplement some of those issues. This was not intended purely from electric cars. Battery plays a very critical role, in addressing the energy storage plays a very critical role to sell those resources back to the grid. But that's the premise when we're developing these interactive systems and communication, and that's resulted in the OpenEDR standard that we produced. It kind of gives you a kind of framework of what we're looking at. So when we look at that framework from the lens of transportation, it does become complex, right? But the complexity is also can be broken into simplicity. So if you look from the EV, we do have our network management for chargers and grid connections. We have charging systems, and then we do have electric grid domains, right? From when domains, when we talk about electric grid, talk about transmission, distribution, or a campus, large campus or community, and of course a building, a facility, which we sometimes call behind the meter or customer sited. When we talk about the smart grid leverage, the more closer we go towards behind the meter or the customer side or the residence or a commercial building, the more closer integration we need with the power systems in the market, right? Because there are too many systems and too many diverse ownership requirements. So how do we move towards that integration? And we also need more interoperability. So one standard cannot solve the problem. OCPP cannot solve the problem. So we need more standards. And then also it's an important thing is enhanced access and value to the resources. The more we move towards the right, the resource value becomes more important to the grid. I won't touch upon the overall value of how the resource could be valued in this, but the important thing here is the complexity can be broken down in a very simple way, and we need to start thinking about how these electric vehicles can become a value to the electric grid. Talking about disruptions, right? So we talk about what is happening in the electric industry globally and what's happening in the United States, but thinking from the disruption, there are a few disruptions happening in the United States. The first and the foremost disruption is looking from the lens of charging. Okay? So when we talk about the charging availability, it's a very important consideration. Always link the sale of electric cars to the sale of availability of the charging infrastructure. Yes, some of them might be 5%, 10% of the populi might be more interested in buying electric cars and going through a trouble, but a lot of people would believe that charging is required for them before they buy an electric car. And that's where charging availability is important. The second aspect is the experience of that charging availability. How does the customer feel? Is it nice? Is it easy? Is it accessible? Right? And then what happens with the roaming, right? In case I go there and go from one network operator to another network operator, one state to another state, and probably one country to another country, where a lot of things may change, the regulations, the utility, and etc. what happens? Can I continue to charge? I don't have to worry about that in the United States when I have an internal combustion engine car. I can go and fill my gas at any gas station across the planet. I can across the country. I could move from California to New York and not be worried about lack of availability of my refilling or gas stations. We need to get there, and that is another one a very important distinction that's happening, and particularly with residential public charging. How we can give this collective experiences for customers to enable that, so that OEMs feel comfortable making cars and selling cars because now people are there to buy the cars, and they feel comfortable about all the infrastructure that's available. When we talk about the plug and charge or PNC in short, the authenticated and seamless EV charging when plugged is very critical. This is something that I have personally experienced, owning a car, how cumbersome it could be having many different cars and going through a lot of hoops to charge the car. If you look at the NACS or the Tesla superchargers, how seamless it is. Just plug it in, it recognizes everything, boom, you get to go and charge. So industry working towards that is becoming very, very important, and OEMs are recognizing that. And of course, the roaming and how we can have billing and multivariate, CSOs interoperate. It's a very important area that we're looking at. So when we talk about the seamless experience, you can't think about not talking about the superchargers and North American charging standards. One of the disruption that has happened in line 23 primarily 1.5 years ago is almost close to 27 automotive OEMs transitioning to NICS, making an announcement. This was just unheard of. 5 years, I couldn't even think about that. Hey, General Motors or Ford or Toyota would be agreeing to say, hey, I would have my car ready and have my systems ready to be able to be charged at the NICS, and Tesla making those systems available. But now we are, and that one of the drivers is the seamless experience and the availability of the charging infrastructure so that they can sell more cars, right? Tesla experience is a phenomenal experience in the charging. So that's one of the things, and now it's being standardized, thankfully, under Society of Automotive Engineers SAE's J3400, which is great, and I think there's a recommended practice already being published by the SAE late last year, and we're hoping that that will continue to evolve and NAICS become J3400 a national standard and can work in close complement to CCS, which is its close competitor for the DC side of things, and then with the J1772, which is on the AC side of things. But there are two other disruptions we are seeing. One is the disruption where automotives themselves are transitioning into charging operators. Okay, so we had seen those experiences in Tesla and maybe Rivian, but they were very selective to those particular manufacturers. They were not based, first of all, on open standards, and they were restrictive to those vehicle owners only, right? But as we start seeing, Electrify America is a good example to Volkswagen. But although it was established as a separate company, the other automotive OEMs are getting into that. One of the way that the consortium of around 7 automotive manufacturers, other than Volkswagen in the US, include GM, Stellantis, Toyota, BMW, etc., established a company called Iona, which is moving into deploying high-scale public charge, super, or what we call a DC fast charging network across the country. So that's a big change and shift we are seeing. What does it mean from a third-party operator, from the OEM-operated infrastructure is a very new for the automotive OEMs. Automotive OEMs in the past have only made the cars and sold the cars, and they're pretty good at it. Now the question really comes is, how are they going to continue to make sure that they can also operate the charging infrastructure and make a business out of it is a very important disruption that we are seeing. And how does it kind of coexist within a lot of third-party operators? Some of you might be on the call today. And there has been always partnerships with other existing charge point operators. In fact, when I was at Greenlots in 2015, we were partnering with BMW, we were partnering with Ford to offer their vehicle owners in seamless charging experience with our charging stations And that partnerships will continue to happen, but the partnership scale are kind of just imploding in terms of what are what's the role of the vehicle manufacturers and the role of the charging operators, and the investment is also happening. So the OEMs are investing because they know that's a way for them to sell more electric cars in the charging operators, and that's also another disruption we're seeing. And I hope there is a coexistence happening between both these communities. So talking about the next disruption, I mentioned about grid management, right? This is the work that I do extensively. We released that analysis about almost 12, 13 years ago of the value chain that has been adopted extensively everywhere. When we talk about electric charging, started thinking, how do I apply that to electric charging? And the question always surfaced to me is, we need to start looking in the lens of electric car and the EV ecosystem. We can't change that. We can't offer a new solution unless we look at it from that lens. And so there are three terms here which I'd like to, some of you may already know, but for those who don't, I'd like to highlight. The one is the V1G, what we call smart or managed charging. This is where we're looking purely from scheduling EV charging at the time when it's favorable both to the owner of the EV as well as to the grid, right? So shifting the charging rather than from 7 to 9 p.m. when there might be peak, but charging after 9 p.m. when there not be a peak, or the price of electricity is low. That's as simple as what we call managed charging or smart charging. The other two terms, vehicle to home or building and vehicle to grid, which are pretty new in the sense of overall market adoption, not new in terms of the knowledge of how it can be done, is vehicle to home and vehicle to building is nothing but where you're using vehicle battery to power a home or a building, okay, in a microgrid setup or an islanded setup, right? What is the difference between vehicle to home and vehicle to grid? When both are discharging the vehicle batteries, and the key difference is vehicle to home, vehicle to building is used. Again, this is from BGI definition, SAE definition, and I don't like to reinvent the whole definitions. Vehicle to home or building is when it's operated in islanded mode. It's not. It's the building might be connected to the grid, but not drawing any power from the grid, but only relies on the vehicle, battery to power partial or the entire part of the building. When we talk about the vehicle to grid, we're talking about the operation that is simultaneously grid connected, grid draw, but at a varying scale. So you might be drawing in only 20% of the grid power, but 80% could be supported by the battery because the price is very high, or the utility is asking you or requesting you to do so. That's the kind of, both are bidirectional, but the context in which you use those bidirectionality is different. And that's what we call the collectively vehicle grid integration, where the vehicle can provide value-added services to this grid. Again, the question comes is there enough value? And that's where the value stacking becomes important. So if you look from the lens of what could be done for managed charging with the infrastructure available, the managed charging are pretty good for TOU rates, demand charge, peak load management. But they're also good for things like T&D cost deferrals, which are the immediate value stream, dynamic prices, etc. And those are also very relevant to vehicle to building, vehicle to grid as well. But the other part that becomes very important is the transactive energy, where you can provide infrastructure or grid cell power back to the grid, net metering, virtual power plant, where you can look at the resource value across the system and not just across a particular building or a home. And so this is where I was looking at the study. I also an editor at the Applied Energy. It's done at Germany, where they looked into whether do we need enough the stationary storage, or how much of the stationary storage could be deferred because the vehicles are providing the similar services what the stationary storage can provide. And the study was pretty immense. Said a significant amount of energy storage may not be necessary if the vehicles are able to be incentivized to provide these kind of services across the grid and can supplement some of those needs. So this is the same Airbnb model or the Uber model. They're looking at how we can maximize the use of resources. And of course, there are battery degradation issues. Of course, there is a value issues. Is it worth doing it for $100, $200, etc.? But those are all the questions that could be answered when we see that there is a value. The other aspect of this, looking from the charge point operators, and not just from the charge point operators, it's also looking from the automotive OEMs lens, right? A lot of work that has been done, and you guys might be familiar with if you're on the charge point side of the software development charge point, is that infrastructure we talk about EGI is provided through regulating the charging via a charging station. But there is also what automotive OEMs are working on, primarily driven by this platform called Open Vehicle with Integration Platform, OVCHIP. Some of you may have heard that, where onboard telematics from the vehicles is used as a way to regulate this without relying on the charging station. There are some, of course, advantages and disadvantages of every technology out here, and the advantage of this is, driver preferences knowledge and the battery state of charge knowledge and better understanding of the battery allocation, etc., are important. And this was the work that I did when I was at Electric Power Research Institute on looking at the OVCHIP use cases, particularly from tariff processing, enrollment, all the metering and data exchange, all the things that are necessary. So this is another way of looking into a disruption, looking into what is happening across the industry when you look at from the telematics perspective. Other thing that is big change happening in the United States, and particularly, is the weather-driven events. In California, we're seeing a lot of wildfires and public safety power shutoffs happening. That how the utilities, automotives, OEM, CPOs are working towards addressing some of the concerns of those outages through battery backup. A lot of extensive work is happening. There are partnerships happening within OEMs and utilities, particularly recent announcement of PG&E and General Motors, and some Ford and other utilities as well in the past, like DTE, etc., helping stabilize the grid during weather-related events. And finally, there are new interconnection. Flexible interconnection is a new term for dynamic controls for the utilities to meet the grid growing power demand, where you're providing a certain amount of power immediately, not the entire power requested, but then adding the rest of the power over a period of time, assuming there's a flexibility in its use by the end user. Everybody asked me, what is the value? So a couple of years ago, I said, let me take a study and then see what's happening across the planet. So I looked at 13 years back, tremendous, like 23 plus studies, and then looked at what are the cost savings that people are seeing available from this bidirectional charging. And the cost savings were all over the world. Different. I looked at Europe primarily and looked at North America. And you look at North America, we're seeing costs a little bit higher when we look at from the European lens. So it's a little less because it's very much contingent upon the market. And then we look at from the vendor's perspective, it's slightly higher because vendors are seeing that there is more potential and then what the public studies are like EPRI or Berkeley Lab or NREL or other institutions in Europe have done. But the underlying theme is, on an average, I'm seeing close to $2,200 per BEV per year. If you take that as a metric per car per year, metric of $2,200. So it's quite extensive over the period of 10 years. If you see the life cycle of the electric car or a car, it's quite a bit of saving. Of course, this is the overall cost that there are, development costs and other costs as well. But just give me a perspective of what is possibility. And then the range was pretty immense. It's 10x difference between the low point of 900 versus 8,000 a year per BEV cost. So let me talk in a couple of slides before I pass it on to Michael in terms of what's happening in the US, disruption from the OCPP perspective, particularly. We are seeing a very extensive recommendations for OCPP by US DOE, particularly OCPP 1.6 and 2.1. As a building block for federally funded chargers. We're seeing the same thing happening with state funded chargers as well, where the language is going in. There's still some deficiencies with the language, unfortunately, where it could be strengthened from the interoperability and seamless integration perspective. But it is becoming a key enabler. OCPP is becoming a key enabler of communications, data security, and making sure that we're not stranding the assets. And then also reliability of operation is a very important aspect because I have a slide just to talk about that. And then, but this is all happening in the public side of the thing, public funded activity. What's happening with the private charge is still a question. As we can see, NLX Way's exit from North America in last year has left the asset standard. People are trying to figure out, what do I do with those chargers? How do I integrate? As long as they're working, they're good. If they stop working, what happens? Looks like we haven't really learned anything back from the totality collapse that we saw with the charging network almost, a decade ago. So electrification strategies, what is happening? Where is the new opportunity? I will, Michael is here. We looked at a new area. What do we need to do? Is a public, infrastructure is available, private infrastructure is available, passenger cars are being electrified, but what's new avenue for those? And this is where we look from the lens of strategy. A lot of strategies are not even real strategies. So we looked at from Richard Rummels, a good strategy, bad strategy principle, which is very comprehensive, and I respect Richard Rummels' view of how we approach a strategy is looking from diagnosing a problem, identifying a key solution, what the guiding policy, what we call, and then applying coherent actions to address those challenges. Particularly in this case, it was focused on electrification of freight trucks and how we can create prioritized charging for those electric trucks. I'll pass it on to you, Michael.
Thank you, Rich. And the exciting announcement that he said, we've now got a 101-page report of this encapsulated in a PDF that just finally arrived this morning. So if anybody's interested in the comprehensive material, please reach out to Rish or I. Our contact information is available at the end, and you can get the full report with the structure. Next slide, please, Rish. So this is a US specific analysis, which I'll repeat a couple of times, but that doesn't mean it doesn't hold value for other things. But thinking about the United States, what we have is an interesting situation where they've shifted to natural gas and away from coal, and as a result, their electrical generation emissions have dropped below their transportation emissions. But that's only of carbon dioxide, by the way, because their oil and gas industry leakage of natural gas and hence methane has increased to the point that it's displaced all the advantages of reducing coal. But that's not all attributable to electrical generation. That's an industrial emissions problem. And some people are working on it a bit at a time, and now less, of course. To that point, I will say that Rish and I started this strategy before the election when there were still headwinds to electric vehicles, but now the headwinds are a bit higher. Um, that isn't a terrible problem, however. But thinking more about the United States and differentiating it, and in the United States, 3.3 million ton kilometers of freight go by road versus 2.4 million ton kilometers by rail, or a trillion, and zero point 0.7 by water. So road is the dominant freight mode in the United States, more than rail and water combined. Further, rail is 35 or 33% coal and a little bit of oil. So that's an interesting thing. The other thing about rail is, unlike the rest of the world, they're not electrifying. So we have this interesting situation where the rail freight is running on diesel and road vehicles, electric trucks in 8 US states are already lower carbon per ton kilometer than on rail. There's other price point differentiators, but in the states where there is strong, still remains strong emissions guidelines, and in a state like California, that actually matters. Now, this is interesting because rail has these calculators, and they have for 20 years on their websites, touting their green credentials. And now the calculators are all wrong. So that's a kind of a fascinating thing. So this is one of the reasons why road electrification is so important in the United States, is that rail isn't electrifying. So that's a real problem there. Next slide, please, Rish. So as we consider what that means, you one of the questions for road electrification from a competitiveness for freight modes, A, it's bigger, B, it is electrifying. We already have a lot of electric road trucks in the United States, while rail is not. Rail's official policy from their lobbying organization is that they are not going to electrify and that it's impossible. Meanwhile, India was at 97% heavy freight electrification in December of last year, and will finish off the last 3% this year. They missed their 2024 target for 100%. In China, the rail electrification for heavy freight was at 72% last time I checked. In Europe, Europe is very heavy on rail, passenger rail, light on freight rail, and so it actually also has a lot of freight that runs by road. So they have a need for more road electrification to decarbonize their supply chain, and they're working on that more aggressively, but with a lot of dead ends like hydrogen are getting in the way in Europe. And so the strategy then for the United States starts with the reality that corporations and corporations, especially the advanced ones like Amazon and Walmart, are responding to demands from their richest and most affluent customers in the blue states of the United States for decarbonized trucking. That will continue regardless of the federal government. Similarly, blue states like California and New York will continue their decarbonization efforts. And so as we look across there, one of the things we articulated in the strategy is a state by state rollout of a decarbonization strategy. Um, Next slide, please, Rish. We have a problem. The problem isn't electric trucks. Electric trucks, the Tesla semi did over 1,600 kilometers in a single day loaded with two brief charging stops in the NACFE's Run on Less initiative. It was built from the ground up to be a battery electric truck, and other OEMs will be getting there. But it's not the trucks then. It's how do we get electricity into the trucks? That's the fundamental problem. And what we found in our assessment was utilities are a significant hindrance in the United States. This is true in other geographies, but it's especially true in the United States. There's a significant shortage of transformers. The United States distribution grid for electricity is weaker than in other geographies like Europe. And so getting enough electricity to truck stops and depots was problematic. And our solution was an obvious one, microgrids with solar and batteries. Right now, batteries are dirt cheap. Um, and solar is dirt cheap. It's less dirt cheap than it was in the United States because the new administration is applying tariffs. But still, let's just run the numbers briefly. The last grid auction that occurred in China for battery energy storage systems closed in December. That was for 16 gigawatt hours of LFP batteries. The LFP batteries, the systems came in, there were 76 bidders for 20-year maintenance contracts, so 20-year life cycle grid battery storage systems. And it came in at $66 per kilowatt hour, which is a tremendously cheaper thing. There's a bunch of initiatives in BES, ground source, in ground-based battery storage systems that that means they've cut prices out of the battery and enclosure and a whole bunch of other things. At that price point, plus cheap solar, putting a big battery to buffer the electricity at a truck stop or a depot, and a container, two or three containers of batteries even, to enable buffered storage makes sense. Now, this is a relatively simplistic curve that we assembled for this purpose, kind of at the midpoint of the United States, to show that we have solar generation over the course of the day. We have a grid connection providing electricity at a stable rate. So one of the advantages of a buffering battery is you exchange energy for power. You take energy at 80% of capacity from the grid connection most of the day to fill the battery, and then you provide power at the point when you need megawatt charging or level 3 charging for two or three trucks when they're there. Um, with solar on every rooftop and solar canopies on the charging stations and over the truck stop, and then in later increments, charging, on solar on nearby fields, what you can get is significant degrees of local, no marginal cost energy, which means you have significant control over the price you charge to trucks for the electricity. So there's some really interesting economic advantages we discovered and looked at. Now, what that means, the next piece of the strategy is incrementalism. You don't start at the end, which is a frequent problem in these spaces. You start with the first increment that makes sense for the volume that you have, and you have a modular solution that can grow over time. So you can charge 20 trucks on the first increment with solar that's easy to put over the existing rooftops, and with a battery system and with charging systems. And then the next increment, you add batteries, you add solar, you add charging stalls, and you can do 50 trucks a day or 100 trucks a day. In the final truck, when you finally get that grid connection, which in the United States can take 7 to 10 years for megawatt plus grid connections, then you're approaching the end state and can incrementally increase your grid connection, increase your batteries, and service a full load of trucks. So 3 to 4 increments over potentially 15 to 20 years turns into a charging solution that grows incrementally and doesn't have overwhelming capital costs at the beginning. Now, this isn't a solution for the faint of heart, and it isn't a solution for small organizations. As we assess the realities of this, what Rish and I did is said, who can afford to do this? And it's big corporations. Pilot Flying J, which runs a huge, I think it's 900 truck stops in the United States. Love's restaurant chain, which is truck stops with food. Same kind of volumes. I think it was just purchased by BP, actually. Then we get to the logistics firms and their depots. There's a company whose name I forgot because I'm terrible with names, which owns 3,600 depots and provides depots as a service to small organizations. So as a real estate play, they can manage this transition and provide a geographical growth. Walmart's with their 4,000 depots and Amazon with their thousands of depots and distribution centers can do this as well, because it requires a central design, tight control of a 15 to 20-year program, and modularity and standardization. And so the purpose of the Open Charging Alliance align well with this from that perspective. Next slide, please, Rish. So, as I said, this is specific to the United States and its constraints. In different geographies, different constraints apply. There are different political headwinds, there are different regulatory headwinds, there are different utility challenges, there are different grid challenges, and there are different corporate structures. And so, while this is fairly tightly applicable as is to Australia, although it requires some localization, for a European country like Germany, it would require a significantly greater localization. So this is of value regardless. The approach is of value. The insights are likely of value, but we strongly encourage people to localize this for their geography. Rish, next slide, please. And so there's a roadmap. Do the same thing. Do the diagnosis. Leverage what policy and there is set targets. Pilot and scale charging microgrids. Engage all the stakeholders. Rish did a stakeholder analysis, which is in the strategy for the United States perspective about who needs to be engaged at each increment. One of the things I will say is that the incremental approach minimizes the stakeholder overhead in the first increment, enabling acceleration of delivery. And then learn and adapt. But that learn and adapt is very specific. It requires strong central change management to prevent local variation, which causes unforeseen costs moving down. So this is your call to action. Do this. Rish and I have done this for the United States. We've thought about it for other countries. We're available to assist local teams to localize the strategy for your geography. And so if you're interested, reach out, get the strategy, and talk to Rish or I. Rish, back to you.
All right. Thank you, Michael. It's been a pleasure to work with you on this. And in my view, Michael, you're one of the best strategists that I've come across. And that's how we looked at it from lens, not just from purely from the technical perspective, but also looking from the lens of what's possible. Now, what do we see from the past and data shows and experience shows, and where do we see it's moving in the future as well. So I will kind of next 5 minutes, I will try to wrap up on the future of the open standards and give some time for Q&A. So when we talk about the future of the open standards, we can't think about electric vehicles and charging infrastructure without thinking about ecosystems. This is the work I did at EPRI, where for the US Department of Energy, where we looked at the electric connected systems and what is connected systems, right? We talk about electric vehicles, we talk about charging infrastructure, we talk about electric grid and its operation, and it's all connected. And the two very important flows out here, or make it three. One is electrical flows, that is very important between charging grid and the electric car vehicle. And then there is, the security and information exchange that happens between all of these entities. And then within these systems, within the electric vehicle system, the charging systems, intrinsically there are information and cybersecurity and components we need. So we broke that into an extensive amount of components. What do we think about the charging infrastructure? What do we think about the EV infrastructure and the grid infrastructure? What components need to communicate and what are some of the integration needs? So it can get complex. So it's very important to start thinking from the lens of a system perspective. That's the key message there. The second and the important thing is the close inner working between a charging operators or a charging infrastructure and an electric utility. So what we're seeing in the US is on the left chart for public charging or the front of the meter or utility sided infrastructure, we're seeing the utilities are giving connection all the way down to the conduits and wires, the trenching, etc., from the transformer and the orange part on the left, and the charging operators and charging manufacturers comes and install the chargers and have it get connected. On the right side, when it comes to behind the meter scenarios, particularly the campus, homes, and building, we're seeing that that infrastructure is provided down to the meter level, and the panel and the charging infrastructure are owned by either the operator or by the owner of that infrastructure. So that's a very important distinction what we're seeing in the US in enabling this charging infrastructure and the growth. If you look at the bottom three, highlights I have, there's significant charging ports that are being planned. This is only L2 chargers, so level 2 chargers, and not looking for the DC fast charging at this point. 3,000 chargers from two very important utilities, Southern California Edison and San Diego, and then close to 5,000 chargers coming from the Pacific Gas and Electric because it has the most amount of geographic presence in the state. So when we look at from the lens of reliability that I mentioned, where open standards play a very important role, and in this case OCPP. One of the studies that shown close to almost 1 in 3 charging infrastructures are not available when the charging, and that's pretty bad. So when we talk about charging needs more in charging, and even the available charging is not there for the vehicles, it's a detriment not just to the charging operators' revenue and business model, but also in people adopting the vehicle. So that is kind of contradicting the 95%, 98% uptime mentions that are out there. The study shows. So the question really comes is how we can work together with the EV operator and make in the world of artificial intelligence and artificial general intelligence, etc. So detect the charger problems and reliability issues or availability issues, and how we can make sure that's the kind of a carrot and stick for private funded projects. Because from the public side, it is required now that maintenance contracts are going into the funding, not just the installation of the charging, but also reliable operation of the charging. But for the private, that is not required. How do we go into a Tesla model where there's a lot of incentives to maintain and operate the charging station reliably, because now you have higher utilization rate coming in. When we talk about the standards, there is a standard soup. I have only touched upon everything from the utility downstream. We talk about the four levels I have classified here. EV and charge point operators, of course, OCPP is the key standard there, and then roaming for OCPI. When we talk about EVSC and CSO2 utility, we're talking about other standards like OpenADR 2.0, IEEE 2030.5, 1815, and Sunspec Modbus. From an EVSC, primarily it's right now driven by 15118, ISO 15118-2 standard, possibly -20 coming up for VGI and plug and charge requirement. I also understand that in Europe and even in the United States, DIN 70121 is pretty active. So when we talk about the OEM to utility, we're talking about the telematics, the widget that I just mentioned, and for demand response, OpenADR, and for energy information, green button. These are all communication and data related integration that we need to think about. From electrical standards, interconnection requirements, the IEC 1547 is pretty big. And its version of testing and certification we're seeing at UL 1741 and 9741 are very important. And I don't want to just stop here at data and electrical standards, but also important to understand with cybersecurity. We haven't touched upon it extensively. We are seeing only at the data in motion cybersecurity with TLS 1.2 and 1.3, and we think it's all secure. What about the data at rest? What about the data that is PII? How are we protecting it? How are we storing it? So there are cybersecurity standards that vary on specific utilities and markets and load under management, etc., that we need to also think about moving forward. So when we talk about the integrated transportation and the grid network for OCPP and open standard stack, there are positive things happening. The Federal Highway Administration and state administrations are requiring things like OCPP and 15118 requirement, including cybersecurity with TLS 1.13, 1.3 for secure management. But there is a huge need to harmonize OCPP stack with other chargers and grid standards, particularly looking at from the open sourcing and how do we make seamless integration of EVs with the grid infrastructure for reliability, lowering customer EV adoption cost, etc. I know I worked with the Open Leader project with the OCA in the past, where we looked at the integration of OCPP with OpenADR, which is IEC 62746-10-1 standard, and but there are other inverter-based resource standards like IEEE 2030.5 and Sunspec Modbus we need to also think about. But in a nutshell, I think OCPP will continue to play a very critical role in the compliance interoperability with EVs as well as upstream with the electric grid. So if I have to summarize everything in 5 bullets of what we have done so far, I think the most important thing is we're seeing that federal and state policy and private investments are driving EV adoption in the US, no doubt about it. There are, of course, cost barriers. We need to get to singularity where the cost of EV is along the par with the current technology, which is the internal combustion engine car without incentives. This is what I meant by separating policies from politics. So you don't have to rely on what happens in the politics, but the market becomes a key driver for adoption. Future proofing is very important. What we have seen in the past 12 years ago, what we experienced with the totality and Blink, and what we are now experiencing with NLX Way, I think we need to future proof both the grid operator and customer assets. And that's very important for not just building the confidence, but the cost recovery of these multivariate systems that we're building. It's not just about electric ecosystem, but it's also about grid ecosystems that's out there to build it. We are seeing a significant potential for OCPP advancement in charging reliability, plug-in charge, roaming, etc. An example of where OCPP has links to other grid standards as well as integration with ISO 15118 is a very good indication where it makes it easy to use OCPP, but also provide other services that are equally important from the ecosystem perspective. That's where the data communication standards, system integration, I think, is one very, very important opportunity that's available and will continue to evolve. Whereas that's something that a lot of audience here can continue to develop new technologies, innovations, and new companies in there. There are disruptive opportunities. Michael spoke excellently about one disruptive opportunity where we are not only making things economical, but also environmentally stable with the medium and heavy-duty truck solutions. We're also looking at from the lens of a strategy, the incrementalism, the standardization, grid management requirements, the stakeholder engagement, etc. I think is very critical. Hopefully, you would be interested to read that 101-page strategy. Michael just had 4 slides, but there's a 101-page report that just got published this morning. I would be happy to share that with you. Please connect to us for a more comprehensive strategy. I would like to kind of wrap up with a mention that one of the work I'm doing right now is really understanding the implication of the NAICS standardization into J3400 and what it means for the grid integration and vehicle VGI services. And one of my conclusions is yet to be published. I'm looking at publication sources right now to publish it. I kind of mentioned that the levels of interoperability, and I'm reading it, just paraphrasing it, so you kind of understand what that means. The levels of interoperability enabled by standards are gateways that integrate electric transportation grid industries. Systems that leverage industry standards foster competition and innovation for relevant stakeholders, any of whom can aspire to advance transportation and grid electrification solutions. And that's where the key open standards fits this bill. You cannot have these siloed solutions and expect the industrial transition move towards an ecosystem, an integrated ecosystem. We have to start thinking about open standards. We have to think about business requirements. Open standards should not be a showstopper to lead innovation. Open standards should be there to foster innovation and new companies and new business solutions. With that, I'll kind of pause here and pass it on to you, Hannah. And by the way, this is our contact information for anything you need for services or any help that you need either from Michael or me. These are contact information. They should be available for you on LinkedIn as well as our email. And thank you all for your time. Over to you, Hannah.
Yes. Thank you very much, Rish and Michael. We are really happy to have you today for this presentation and to hear about your United States perspective. So thanks a lot for taking the time. We have a few minutes left for the Q&A part of this webinar. And as Rish already said, we are really happy to have some interaction and to answer your questions. So to our listeners, you can post your questions in the question box on the right side. And we will have a look at the first question, which is, what implications do you see from the new administration for EV adoption in the US?
Excellent point. I'll make a quick comment. I was expecting this question, so I appreciate asking that question. And that was the reason, of course, we all know that Michael mentioned there are more headwinds than what we thought we started from a year ago in the writing the report, and of course the transportation industry. But we have to understand that transportation electrification is a long-term goal. It's not 4 years, it's a long-term vision. And we have seen this, this is not the first time we have seen this administration, right? We have seen this 4 years ago as well, or 8 years ago when it started, and we have sustained that. So when we think from the battery costs falling, all the reasons that Michael mentioned, and what I think is the headwind, it's the future. It's just that it may have slowed down a bit right now, but the future is there. So I would call upon the industry, and the call action is build a great network, build a great technology, offer this great solution to the customers. Customers will buy it. And we are seeing that in states like California, New York, Washington, Florida, where a significant adoption of EVs are continuing to happen, although it's slowed down a little bit. But we should not just think it from the lens of 4 years. We need to think it from what happens in the next 20 years and next 30 years and the future that we're going to see. Michael, any other comments that you make?
Yes, I would say that the most affluent states, and hence the ones receiving the most high value goods by road freight, are blue states in the United States for the most part. They are continuing with their decarbonization efforts. America's cities are demanding decarbonized freight, and they're demanding quiet freight. There is the strategy that we put together in terms of a geographical dispersal of electrified trucking maps quite remarkably onto that, because those states have also been decarbonizing their electricity and ensuring that it's cost competitive with natural gas and other things. And so as we looked at the regulatory structures that would support decarbonized trucking, as we looked at decarbonized electricity that would support it being decarbonized, as we looked at affluence, all those choices that are outlined in that geographical pattern in the strategy still apply. The federal The federal headwinds are merely that. What I would say is the Walmarts and Amazons of the world. There's a term that's being used right now called green hushing. And green hushing is a report that came out recently, which found major corporations, even in the United States, are quietly going about decarbonizing. They're just not telling anybody anymore. But they are still meeting those targets. And so as we look at that, we think the strategy still is applicable. It's just you have to change how you might sell it. For example, we changed the title slightly because we didn't want to attract too much attention to a certain aspect. But corporations know how to do this. These are strategies for big corporations, and big corporations know how to deal with political volatility and change. They're going to be doing the right thing because electric trucking is cheaper. Total life, the TCO of electric trucks is now break even and dropping. They are lower maintenance, they're lower cost of operations. Reliability is now, 1,000,000 miles in US, those weird imperial units the United States uses. So we're seeing significant warranties that don't exist for diesel drivetrains now. And so it's inevitable. It's just what parts of the country you're going to get a good reception with and from whom, that's a completely different thing.
Yeah, so Michael, what you just said also refers to another question that we got. So is the electrification of trucks the next frontier after the electrification of cars? So maybe you can answer that one. Do you see it as the next big challenge?
Oh, I look at multiple things. I would say there's two 700 container ships on the Yangtze right now that winch charged batteries and containers on and winch discharged batteries off for charging in transshipment port. Those two ships are running 1,000-kilometer routes up and down the Yangtze. That's a frontier. Electrified trucking, we've got lots of electric trucks. It's just a matter of buying more of them, replacing long-lasting diesel trucks, getting the charging in place. It's barely a frontier anymore. I'd say the aspects that need to change still is more OEMs, as I say, need to build them from the ground up for batteries. The OEMs are still using the same ladder frame, and they're jamming fuel cells in there, or they're jamming diesel in there, or they're jamming batteries and electric motors in there. And they got to stop that. They got to build skateboard semi for batteries because that's the winner. And they got to stop wasting time and money on hydrogen. It's same for buses. But yeah, barely a frontier.
All right.
Just real quick, Hannah, if I may, I think one of the areas we also need to think from the electrification for these trucks is looking at the total cost of ownership, not just the first cost, right? Yes, the first cost is high, and we want to work towards reducing the first cost as much as possible. The cost of electric trucks sometimes are even twice the cost of what the internal combustion engine counterparts are. But the right sizing of the battery and then looking from the total cost of ownership is a very critical aspect. In not just look at from one lens, look at from total cost of ownership lens as well.
Yeah, thank you. Yeah, it's time to wrap up this webinar. Unfortunate, I'm sorry for that, but we have to wrap it up now. If you have any questions that we couldn't answer, you can also refer to Michael or to Rish. So you showed your email addresses, so you can reach out to them. You can also reach out to the Open Charge Alliance, of course. You can email us at info@openchargealliance.org. And then we will come back to you and answer your questions. So again, I would like to thank you, Michael and Rish, for joining us today and for sharing your insights. I think it's really valuable to have your insights in your presentation. So thank you. And for now, I will close the session and I will wish you a good day. So goodbye.
Thank you, everyone. Thanks for your time.
Thank you, everyone.